All right, so I want to take a look at a way of organizing your thoughts when you're factoring a trinomial, okay? All right, so let's try to factor this trinomial. So we have here three terms, and the first step when you're factoring any kind of polynomial is always to try to factor out the GCF. So looking at these three terms, I see that the largest number that goes into 30, 111, and 36, the largest number that goes into all three of those is 3. And I also see that they all have the variable x. So x is a part of the GCF. You always take the smallest power of x that you see in any term, or the smallest power of the variable for that matter. So then we're going to factor 3x to the third power out of this trinomial. So dividing this first term by 3x to the third gives us 10x squared. Dividing the second term by 3x to the third gives us positive 37x. And dividing this last term by 3x to the third gives us negative 12. All right, so now we factored out the GCF. So we've isolated the monomial factor. There's one monomial factor. So what we're going to do is we're going to try to factor this trinomial. If this trinomial does have more factors, those factors would have to be binomials. So I'm going to assume that I have two binomial factors. And the method I'm going to use is kind of reversing FOIL, okay? What I'm going to do is I'm going to acknowledge that this term right here comes from the F part of FOIL, first times first. And I'm going to make a table to organize my thoughts. So for the F part of FOIL, there are two ways of getting that. For the F part of FOIL, I can either multiply a 1x and a 10x, a 1x and a 10x, or I can multiply a 2x and a 5x. Those are pretty much the only two possibilities for giving me my 10x squared. It's either going to be 1x and 10x or 2x and 5x. I also want to acknowledge the fact that this term here comes from multiplying last times last, the L part of FOIL. Well, there's actually a few ways of getting 12. You can multiply 1 and 12, you can multiply 2 and 6, or you can multiply 3 and 4. So I'm going to try all of these possible combinations. I'm going to try the 1x and the 10x with 1 and 12, 2 and 6, and 3 and 4. And I'm going to try the 2x and the 5x with 1 and 12, 2 and 6, and 3 and 4. And I make this table just to organize my thoughts so I know when I've tried a particular combination already, okay? So here's the problem that my students had today. My students, when they saw the 10x, they kind of fixated on 2x and 5x. 2x and 5x. They kind of assumed that this pair here was going to be the pair that was going to work. All right, and then they went through, well, let's try the 1 and the 12 for last. Let me see. If I'm going to use the 1 and the 12, I cannot put the 12 here, because 12 and 2 have a common factor of 2, and I've already taken out the monomial GCF, so I know that there is no other common factor to take out of this. So if I'm going to try 1 and 12, the 12 would have to go here, and the 1 would have to go here, because the 12 cannot be with the 2. They have a common factor. When I do outside, I would get 48x. When I do inside, I would get 5x. So I'm checking the O and I from FOIL to see if I can get the middle term. The middle term comes from O and I. Well, let's see, 48x and 5x, adding or subtracting those couldn't possibly yield 37x. So that means that 1 and 12 are out of the running now. 1 and 12 cannot work with 2x and 5x. So I cross those out because I know they won't work. So let's try the next pair of last factors. We just tried 1 and 12. Let's try 2 and 6. Oh, but there's a problem. Remember, we couldn't put the 12 in the parenthesis with the 2 because they have a common factor? Well, 2 also has a common factor with 2, and 6 also has a common factor with 2. So I wouldn't be able to put the 2 or the 6 in this parenthesis. So that means that these would not work. So you don't even have to try them. They will not work. There's no place to put the 2 or the 6. So let's try this last pair, 3 and 4. 3 and 4. Well, let's see here. If I'm going to put the 4 in any parenthesis, it can't be this first parenthesis because there's a common factor of 2 there. The 4 would have to go here, and the 3 would have to go here. Let's try outside, outside. Outside, outside gives us 8x. And inside, inside gives us 15x. There's no way of me getting 37x by either adding or subtracting 8x and 15x. So these don't work either. So this is the problem my students ran into. They tried every possible combination of the factors of 12 with the 2x and the 5x, and they didn't find one that worked. Well, that just means that 2x and 5x will not work, so I can mark those off the list of first. And some of my students thought this meant that the polynomial was prime. The polynomial is not prime. You still have to try the other factors of 10x squared, x and 10x. So let's try x and 10x. So we'll put in x and 10x and see if we can find the last pair that works. Well, if I'm going to use 1 and 12, the 12 couldn't go in the parenthesis with the 10 because they have a common factor. So the 12 would have to go here, and the 1 would have to go here. In this case, outside, outside gives me 1x. Inside, inside gives me 120x. Needless to say, those aren't going to work to give me 37 if I add them or subtract them. So I move on to the next pair then. That means that the 12 and the 1 just will not work. So 12 and 1 do not work. So let's try the 2 and the 6. Oh, but wait. Neither 2 nor 6 would be able to be put into this parenthesis because both 2 and 6 have a common factor with 10. So right away I can mark off 2 and 6. They won't work. All right. So I only have one more thing. This is the last pair to try. The 3x, or the 3 and the 4. Well, if I'm going to place the 4 anywhere, I can't put the 4 here. It would have to go in a parenthesis that doesn't have a term with a common factor. So the 4 would have to go here, which means the 3 would have to go here. Let's see. Outside, outside would be 3x. Inside, inside would be 40x. I could get 37 with a 3x and a 40x as long as if I want positive 37, the 40x would have to be positive and the 3x would have to be negative. When I combine these two, I would get my 37x. That would be perfect. In order for me to get negative 3x though, when I multiply x by 3, I have to get a negative answer, so I'm going to make the 3 negative. And in order to get a positive 40x, when I multiply 4 by 10, I have to get a positive, so I'm going to make plus 40x. And it turns out that even though I had to go through the entire list, I did find 2 factors that worked. These factors definitely work for first, because I forced them to, by only using factors of 10x squared. These factors also have to work for last. 3 times 4 is negative 12, because I forced myself to use only factors of negative 12, or 12. And then I just checked outside, outside, inside, inside to see if I could make the middle term. And it worked out. So a lot of times when you think a polynomial is prime, all you really have to do is be methodical about it and check each of the choices that you have for first, and last. So this way of organizing your thoughts helps me. So maybe it'll help you.